Physics 2, Lab 3. This is the link to my code. These were my initial values based on my observed calculations for the bar magnet. The purpose behind this lab was to measure the observational values of a magnet and account for Earth's magnetic field, and then to create a computational model to compare our measured values against to see how accurate we were. Our assumption was that we have accounted for Earth's magnetic field in our computational model and in our calculations. These were the fundamental concepts and calculations behind it. Here we took the data we plotted and extracted N, K, and mu. This here is where we took our measurements in our app on the phone in microtesla and converted it to Tesla to account for this constant 4 pi over mu naught. This is my computational model. We can see that the perpendicular arrows magnetic field values are all the same, which is good, and that the on-axis values are also of the same magnitude. What if? So for part 1, if we had not compensated for magnetic north, our results would have been inaccurate. That is, the mu and B-net values would have been larger or smaller than they actually were because of Earth's magnetic field would have been a factor in the calculation that we did not account for. If we had 2 identical magnets, this would have increased our magnetic field by a factor of 2 or a little less, and that's accounting for the small distance difference for putting one magnet behind the other one or in front of the other one. It's not quite at the same observation location, so the distance is going to be a little more or a little less than 2, whether we put it in front of or behind the original magnet, respectively. And that's it for Lab 2.